trig functions. You'll learn a lot. In fact, the truth is in math, integrals are still being explored and discovered and researched. And in fact, there are certain integrals that we really only know how to find by computer models. We don't know how to take the integral of. We know that every integral has an answer because every function has a derivative. So then every derivative needed to have a function prior to that. But to be quite honest with you, there are expressions that we only integrate with calculators and computer models at this time, which is weird. So you're not going to learn everything that there is to know about integration in this class. All right, well, we're going to look at the integrals of some trig functions that are common and ones that we can think about by just understanding that the integral is just the antiderivative. So I'll start with the integral of the cosine of x dx. And as I think about this, all I'm really thinking about is, what function has a derivative that's cosine? Well, that would be sine of x, but these are indefinite integrals, so I'll put plus c. Likewise, the integral of sine of x dx. The integral of sine, what function has a derivative equal to sine? Well, the derivative of cosine is negative sine. So I need to indicate a sign change here. So the integral of sine is negative cosine plus c. If you took the derivative of negative cosine x plus c, you would get positive sine x. Some other trig functions whose derivatives we could recognize: the derivative of secant x tangent x, the function whose derivative is secant x tangent x will tell us the integral of secant x tangent x dx, which is secant of x plus c. In a similar fashion, the integral of cosecant x cotangent x dx would be negative cosecant x plus c. The integral of secant squared of x dx, if we, I'm going to write it over here. I'm having a little problems with that part of the screen. So the question we want to ask ourselves is, what function has a derivative of secant squared x? Well, that'd be tangent of x plus c. And what function has a derivative that is cosecant squared x dx? Well, that would be negative cotangent x plus c. You might remember that when we did derivatives, that the derivative of any trig function that started with a c had a negative answer. We're undoing the negative now, and so we are going to need the negative here belonging with that trig function that starts with the letter c. So you're going to want to watch for that. When you are doing these integrals, you can there are multipliers. That's totally fine. You can add and subtract. You're just going to integrate each expression, and then you can keep the same addition or subtraction that's in there. The integral of sine, remember, is negative cosine of x. And there's like a plus c here that we really don't write. I'll tell you in a minute why we don't write that, but you can kind of keep in mind that there's like this plus c here. And then the integral of cosine is sine, and there's this multiplier. Remember, this one had a plus c. Well, constant plus a constant just combines to another constant. So we won't write the plus c more than once ever in a problem. We'll just write it at the end. So if you have a number out front like this, that number is just going to be a multiplier for your function inside the integral. So after you do the integral, you'll just multiply the answer that you get by, in this case, -3. Now this one is interesting because if you look at this, you might notice the secant squared. But what about the 1? So we can have a mix of some polynomial expressions and some trig expressions in the same problem. So I'm going to do -3 times, well, the integral of 1 is x, and the integral of secant squared is tangent of x, and then there's a plus c at the end. we can distribute this and write this as negative 3x minus 3 tangent of x plus c. You might wonder, like, why didn't I distribute the negative 3 to the c? Well, I mean, you could actually. But what's negative 3 times a constant? It's just a constant. And so when you take a constant and you add it to another constant, or you multiply it or divide it by a constant, it just remains a constant. And so we really just leave that plus c there at the end. An integral actually is going to tell us some information about a graph. And this will be something we are definitely going to take a deep dive into and explore a lot more. What an integral tells you when you're looking at a graph is an integral tells you the area between a function. Maybe I'll call this graph f of x, and the x-axis. And specifically, if the area is above the x-axis, then you're going to get a positive value. And if the area that we're looking at is below the x-axis, then we're going to get a negative answer. And I think a quick example or two will help to clarify this. So let's say I look at this picture. And let's say that I tell you, wow, let me change the size of this highlighter. Let's say that I'm looking at this area of f of x, in between f of x and the x-axis from 1 to 3. Maybe I tell you that this area is 5. And maybe I tell you that this area, I have a little trouble with my highlighter, is 7, right there. And maybe I tell you that this area is 2. Well, we can use integrals to kind of reference this area. If I talk about an integral of my function f of x, an integral is going to be used to describe the area between f of x and the x-axis. But quite often what we'll do is we'll put a starting and an ending value. So for example, let's say I put some numbers here from 1 to 3. This is my yellow region. My yellow region could be described as the integral from 1 to 3 of f of x dx. And the answer to that is 5. That is the area between f of x and the x-axis, starting at 1 and ending at 3. So these right here, these numbers, this is called a definite integral, which we'll look at tomorrow. Those numbers help you know where to start and stop for your area. Likewise, let's say I wanted to do the integral from -2 to 1 of f of x dx. So from -2 to 1, that's my blue region. Now this says 7, but what I'm going to write is -7. And the reason I'm writing a negative is because we are below the x-axis. I kept the 5 positive because that area is above the x-axis. So that sign is telling us where it is, above or below. You might notice these answers do not have a plus c. The reason why is because we have this definitive starting and ending spot, so we do not have a plus c. As soon as we put these numbers, these limits on our integral, we don't have an indefinite integral anymore. We have a definite integral, and so we don't use the plus c. This is my green region from -3 to -2. You might notice my smaller numbers at the bottom, my bigger numbers at the top. And so this has an area of 2, but it's below the x-axis, so it'll be -2. You might remember that I, a while ago in this lesson, told you that this is like the letter S for a sum or summation. Well, this letter S can help us accumulate areas. Now, when we accumulate areas, we're going to go from left to right. as we accumulate areas. And so this is the general idea as we're going to go from left to right. If we want to go from right to left, we're going to have to do something kind of unusual, which we'll talk about later. But if I'm going to go from left to right, let's say I want to go from -2 to 3. What I'm going to do is I'm going to accumulate my areas. I'll start at -2 and I will do my blue region, which is -7 because I'm below the x-axis, and I'm going to combine with that, add to that. That's why this is like an S, a sum, the area from right where I left off 1 all the way to the end of my integral at 3. Oops. And so this would accumulate to an area of -2. This answer is negative not because all of the area is negative, but because more of the area is below the x-axis than is above the x-axis, according to the made-up numbers that I gave us. Let's do one more. I could do from like -3 to 3. I could have done many other combinations of integrals here, but we'll just explore this. Well, I would start at my green region from -3 to -2, which has an area of -2. Then I would combine with that my blue region, which has an area of -7, and this goes all the way to the end. I would combine with my yellow, and this has an accumulation, a summation of an area of -4. And again, this is negative because more of the area is below the x-axis than is above the x-axis. And, oh, there's more. This is just a summary of some rules here. If you are multiplying by a constant, you can just multiply by a constant as you do your integral. Here's a summary of the power rule, which we talked about earlier. If you have two different expressions being added, you can just take the integral of each part and continue adding. Same idea when you subtract. An integral of a constant, like the integral of 5, would be like 5x plus c. And then a summary of our trig rules. This is a squared, and I'm not sure why I typed like this. Sad. Okay, there were 3 others we didn't list here, so I think the ones in your notes are a little bit more complete. All right, that is the end of our lesson today for 5.1.